Hey everyone, in this video I will show you the electron configuration of AP2 plus and AP3 plus. This is ferrous ion and this is ferric ion, right? So let us write the electron configuration. Remember these two are the ions. So before writing the electron configuration of any ion, you have to write the electron configuration of the neutral atom. That is, this is iron, its atomic number is 26. So at first we have to write the electron configuration of this element. So let us write. We know that in first shell we have one subshell which is 1s. In second subshell we have two subshell. In second shell we have two subshell which is 2s 2p. In third shell we have 3s 3p 3d. In fourth shell we have 4s 4p 4d, then 4f, right? So we can draw a line like this. This will help us to find electron configuration quickly, right? Okay. Now look, to do electron configuration, we'll draw a line 40-degree angle like this. Then here, okay, so our first electron, our first two S subshell can take maximum 2, P subshell can take maximum 6, D can take 10 and F can take 14. So look, 2 electron will go to 1s2. Then we have here, from here you have to start here, 2s2. After 2s2 you have to draw a line like this, 40-degree angle, like 40-degree angle. So we are getting here 2p 6. You know that P subshell can take maximum 6. Then 3s2. After 3s2 you have to go here, that is 3p then 4s. So write 3p 6 then 4s 2. Now count 2 4 6 10 12 12 plus 6 18 18 plus 2 20, but here you have 26. So now you have to consider this 3d 4p, right? 3d 4p. So in 3d you can place 10, but here you have only 4. Okay, 2 4 6 2 4 10 12 16 then 18, so 20, then we have 6, 26, right? Okay, now we'll write the electron configuration of AP2 plus. AP2 plus means you have to remove 2 electron from the neutral atom. So if you remove, then you have 24 electron for AP2 plus. These 2 electron will go from the outermost shell. Outermost shell can be found by looking at the value of principal quantum number n. Here the highest value of n equal to 4, right? So 2 electron will go from this. So this is the electron configuration of Fe2 plus. So what will be the electron configuration of Fe3 plus? So in Fe3 plus you have to deduct one more electron from Fe2 plus. This is the electron configuration of Fe2 Fe2 plus. So for 3, just deduct 1 electron from that is 23. So for this, the next electron will go from this 3D. Why 3D? Look, because this is the highest energy subshell. Okay, for 3D, n plus L value equal to, for n 3, and for D we get L value 2, 5, right? And for 3p6 we get n plus value 3 plus 1, that is 4. So the highest energy subshell is the 3D shell. So electron will go from here. So you have to deduct 1 electron from here. So this is the electron configuration of AP2 plus. So at first we are writing the electron configuration of AP, then from AP we'll deduct 2 electron for 2 plus, then we'll deduct 1 more electron from AP2 plus to get the electron configuration AP3 plus, right? Okay, I am going to show you another method to write the electron configuration of iron 26. You know that we usually distribute electron to S, P, D and F subshell, right? This is your first subshell, this is second, this is third and this is fourth. You can tell me that S can take maximum 2, P can take maximum 6, D can 10 and F can 14, right? So again I will write this SPDF. So to write the electron configuration of iron, we need to write the orbital sequence. How to do that? At first you have to take SS just once, then you have to consider these two at the same time, PS, and you have to write it twice. Then you can write, you have to consider these 3, DPS, DPS, you have to write DPS twice, and then you have to consider this 4 subshell at the same time, FDPS. You can write FDPS to any times according to your atomic number. So say with me, SS, PSPS, DPS, DPS, then FDPS, FDPS, FDPS. There is no limit for writing FDPS. Again say SS, PSPS, DPS, DPS, FDPS, FDPS, FDPS. Right? Okay. Now distribute electron. We have 26. So 2, 4, 10, 12, 18, 20, 26. So already we have distributed this 26 electron. So this S start from 1s. The second S will be 2s, then 3s, then 4s. And P start from 2p, 2p, 3p. D start from 3, then 3d. So this is the electron configuration of neutral iron. And for AP2 plus, just remove 2 electron from 4s2, and for AP3 plus you will get the electron from here, that is you have to deduct 1 more electron from AP2 plus, that will go from the highest energy subshell here. So this is the easy way, right, to easy things to write the electron configuration of AP2 plus and AP3 plus and AP.